Hello friends, today I will discuss about current reversal guard logic in POTT scheme. That is how the current reversal guard logic save the healthy circuit tripping due to fault in the parallel feeder in permissive overreach transpective scheme. So what is current reversal? So in this figure, in between substation 1 and substation 2, one double circuit line exists and the length of the both the circuit is very less. So circuit A and B and circuit C and D is connected between substation 1 and substation 2. Substation 1 is connected with strong source and substation 2 is connected with weak source. So the CB position has been shown for both the circuit. So a fault occur at point F, which is very close to B point and which is far from the distance from substation AN in the circuit AB. So due to fault at point F, the relay detection for different end of the both the circuit has been shown in this figure. So this fault point will be located from substation AN relay at zone 2. So AN relay will detect this fault at zone 2 location, and for BN relay it will detect at zone 1 and zone 2 also. And again for C and D circuit, that is C end relay, it will detect zone 2, and for D end, if the fault point is very close to B point, then it will detect at zone 4. Since fault at point F, which is located from B end relay at zone 1, the relay will send an instantaneous trip signal to its circuit breaker. So CB at B end relay will trip instantaneously and breaker will be off. Due to tripping of the circuit breaker at B end relay, the current flowing in the CD circuit will reverse as shown in this diagram. So the relay for different end has been shown in this diagram. So now A end relay will detect this fault as zone 2 as it was earlier, and since zone 2 is a time delay tripping for POTT scheme, it will trip after the communication time delay, that is normally 2 to 3 millicycles. And B end relay, it will since it is already send a trip signal to the circuit breaker, it will trip the circuit breaker. Again for C end relay, it will the zone 2 detection will be reset since it will be a reverse fault and fault point is located far from the zone 4 detection. And in case of D end relay, it will detect the fault at zone 2 location due to very short length of the circuit, both the circuit. So we can see the current reversal exists in case of C and D end relay. But in case of C end relay, since the fault point is located, not detected for zone 2 location, since fault point located far from zone 4 location. But in case of D end relay, it will detect at zone 2 due to the short length of the circuit. Now let us discuss about the POTT scheme and also see the effect of the current reversal in case of POTT scheme for short line in case of parallel line fault. So the fault located at point F, and due to fault at point F, the flowing of the fault current has been shown in this figure. So in this AN relay, since AN relay detected the fault at zone 2 location, it will send a permissive signal to the far end relay. And since BN relay, it is detected zone 1 and zone 2 location, it will also send a permissive signal to the far end relay. So since BN relay send the permissive signal to the far end relay, and in case of AN relay, since there is a zone 2 pickup and it will receive a permissive signal from the far end relay, it will wait for the communication delay, which is normally 2 to 3 cycles, and it will send the trip signal to the circuit breaker. But since BN relay detect the fault at zone 1 time also, it will send the trip signal instantaneously to the circuit breaker. In case of CD circuit, the current flow from C to D to the fault point. So C and relay detect this fault at zone 2 location Therefore, it will send a permissive signal to the far end, that is D end relay. Again, for D end relay, since it is a reverse side fault, it will detect only zone 4 location, but it will not send any permissive signal to the C end relay. So C end relay will not trip. So due to tripping of the circuit breaker at B end instantaneously, and since the A end relay will wait for the communication time delay, so there will be time delay of almost 60 millisecond or 2 to 3 cycles. The current flowing at CD circuit will reverse. That is, now the current will flow from D to C to the fault point. So thereby the relay detection, that is the relay detection at C and relay, the zone 2 and zone 3 detection will be reset since it is a reverse side fault and fault point is located, that is the far from zone 4 locations. Again, for DN relay, since DN relay already received the permissive signal from CN relay, and it will detect at zone 2 locations due to current reversal. Since the current is flowing now at fault point from D to C to the fault point, and due to the very short length of this circuit, the DN relay also detect this fault at zone 2 location. So zone 2 detection and permissive receive satisfied for DN relay also, and therefore the AN relay and DN relay will trip simultaneously. So due to fault at parallel feeder, there is a tripping of the healthy feeder, that is the CD circuit at DN relay. So this might be stopped by current reversal guard logic. So in case of current reversal guard logic, due to current reversal for C and D end relay due to tripping of the circuit breaker at B end, the current reversal guard logic will be activated, and in case of current reversal guard logic, a time delay setting is given. So after that time delay, the zone detection will be activated at substation C end and D end relay. So before the detection of the zone for C and D and relay, the A and relay already send a tripping signal to the circuit breaker. So thereby tripping of the A and circuit breaker, the D and relay will not detect this fault at zone 2 location. So in case of D and relay, the zone 2 detection and permissive receive signal is not satisfied, and also before the detection of the zone 2 location, and this permissive signal might reset due to setting of the current reversal guard logic. So due to activation of the current reversal guard logic, due to current reversal for tripping of the one of the circuit at zone 1 time, this healthy feeder tripping can be avoided. So this is how, in case of current reversal guard logic in POTT scheme, the healthy feeder tripping can be avoided where one of the substation is connected with strong source and other substation is connected with weak source. So friends, if you like my video, then do subscribe my channel and also press bell button for notification of videos to be uploaded in future. Thank you for watching this video.